Okay, let's dive right into this. Welcome to this explainer, where we're going to unpack a truly fascinating journey in the world of artificial intelligence. We're looking at the evolution of search. How AI basically grew up from just blindly matching letters on a page to actually thinking, reasoning, and acting like a super smart research assistant. Now, if you've been following AI at all, you've probably heard acronyms like LLM and RAG thrown around all the time. Well, today, we're going to break down exactly what those mean, how we got here, and why this latest shift to something called Agentic AI literally changes everything about how we interact with information. But to really understand where we are right now, we kind of have to understand why the old way was so incredibly frustrating. I mean, we've all had this experience, right? You type a question into a search bar, you hit enter, and boom, you're flooded with thousands of results. And yet, somehow, absolutely none of them actually answer your question. So why did that happen? Well, for a really long time, search engines didn't actually understand what you were asking. They didn't understand language at all. Instead, they treated your words simply as symbols. If you typed the word bark, the engine didn't know if you meant a dog or a tree. It literally just looked for the letters B, A, R, and K. Which brings us right to Section 1, the limits of early search. Let's take a look at exactly why those early systems hit such a massive wall. So, early systems simply scan for exact keyword matches. They used these things called inverted indices, which are basically like a giant map at the back of a textbook, linking words to documents, and then they ran some math formulas to calculate how often your keyword popped up. But that created a fatal flaw, and that is ambiguity. Let's take a really simple word, Python. If you go to a basic keyword search engine and type help Python, what exactly are you looking for? Are you a frustrated programmer trying to fix some computer code? Or did you just buy a pet snake that is refusing to eat? If it's the snake, let's be honest, a coding forum is definitely not going to save your fingers. A traditional search engine has literally no idea. Synonyms, context, complex human intent, all of that was completely invisible to those early systems. The burden was entirely on you, the user, to guess the exact right words the author of the document might have written down. To fix this, we needed a huge technological leap, and that leap was semantic search. Think of it kind of like this. Traditional search is like a very, very literal-minded librarian. You ask for books on felines, and the librarian says, sorry, we only have books on cats. We have 0 books with the word feline. Semantic search, on the other hand, is much more like an intelligent friend who actually grasps your intent. They know that feline and cat mean the exact same thing, even though the words look completely different. Instead of treating text as just empty symbols, we finally started representing them as actual human language. Now, what's really interesting about this slide is how we actually teach computers to do that. We do it using vectors, which are essentially high-dimensional number representations. What happens is large neural networks read massive amounts of text and learn the context of words. And over time, they create this incredible kind of mathematical map. Because coffee and espresso show up in similar contexts, mugs, mornings, cafes, the AI assigns them very similar number coordinates, like 0, 1, 0. But a word like house, that gets a completely different coordinate, like 100, placing it super far away on the map. This was huge. It allowed systems to finally approximate true understanding. It actually knew espresso and coffee lived in the exact same neighborhood. And then, as we all know, the entire world shifted. Welcome to Section 2. The LLM boom and its fatal flaw. Because despite their mind-blowing power, these new models came with a pretty huge vulnerability. To really grasp this flaw, remember that large language models, your ChatGPTs, your Claudes, they digest massive, massive corpora of text to learn the deep patterns of human language. They're essentially predicting the next most likely word to generate these highly articulate, completely novel answers on the fly. But that training process is incredibly long and super expensive. And because of that, LLMs are locked in time. Realistically, an LLM's knowledge basically ends the day its training finishes. It has no idea about the news that broke this morning. And even more importantly for businesses, it definitely does not know about your private company data, your secure internal emails, or your proprietary sales reports. So if you try to use it for your specific business needs, it just guesses. And that is exactly what leads to those dangerous, infamous AI hallucinations we've all heard about. So, how do we solve this massive knowledge gap? Well, that brings us straight to Section 3, RAG, which acts as the AI's external memory. The crucial solution here is Retrieval Augmented Generation, universally known as RAG. And it's honestly such an elegant fix. When you ask a question, The system first does a targeted search in a specific up-to-date knowledge base, like, say, your company's private files. It retrieves the relevant documents, bundles them all together with your original question, and basically tells the LLM, hey, answer the user's question, but only use the information I just handed you. This was a total game changer. It allowed businesses to finally get highly accurate, cited answers using their own private current data. It drastically dropped hallucinations, and the absolute best part, they could do all of this without having to constantly pay to retrain the AI from scratch. For a while there, RAG was seen as the holy grail, but we pretty quickly hit a ceiling, which leads us to Section 4, static pipelines versus agents. This is where we see the next massive disruptor in the space. Notice the stark contrast here. Traditional RAG is completely predetermined. It relies on a linear path that is set in stone by a programmer. You ask a question, it searches exactly once, and if it fails to find the right document, well, the final answer is just going to be wrong. Developers tried to make it smarter by adding clever little tricks, like re-rankers to double-check the search results. But fundamentally, it was still a very rigid one-way street. Agentic RAG, however, shifts the entire paradigm. We are moving into the realm of autonomous decision-making systems. Instead of just following a static script, an agent uses the LLM as its brain to actually reason about the task, plan out steps, and use tools to solve complex problems completely on its own. Which means, welcome to Section 5, the era of autonomous AI. We have officially moved from a system that just passively reads documents to a fully intelligent research assistant. Let's move to and see how this builds in a real-world scenario. An autonomous agent today actually has a toolbox. It has memory, it can make plans, it can criticize its own work, and it actively decides when and how to search. Say you ask an AI to compare your company's Q3 revenue to a competitor's. A simple RAG pipeline would completely fail at that. But an agent? It follows these steps autonomously. Step 1. It stops and decides, yes, I actually need to look this up. Step 2. It chooses to search your private internal database for your revenue, and then deliberately chooses to search the public web for the competitors. Step 3, it formulates the perfect search queries for both distinct tasks. Step 4, it looks at the results, realizes, wait, I'm missing November's data, so it searches again until it's completely satisfied. Only then does it move to Step 5 to synthesize all those different sources and generate your final answer. It can compare sources, invoke APIs, and validate claims completely on its own. It's really incredible. And this brilliantly illustrates the complete evolutionary timeline we've been walking through today. We started way back at the early web, where systems were just dumbly matching exact symbols and keywords. Then we moved to semantic search, where vectors finally allowed machines to understand the math of human meaning. After that, we experienced the massive disruption of LLMs and RAG, which gave AI the power to generate text while tapping into an external memory. And today, we're at Agentic AI, where multi-step reasoning allows the system to actively hunt down the truth all on its own. Which brings us right to our final thought, the overarching lesson from this incredible journey, from simple keyword search all the way to Agentic RAG, is this. The hardest part of AI isn't generating the words anymore. Getting an AI to talk smoothly is relatively easy now. The true challenge, the real magic of where this technology is heading, is in the system deciding what to look at. As AI fully masters the ability to autonomously hunt down and verify the truth, we really have to ask ourselves, once the AI knows exactly where to look, what will it uncover next? Thank you so much for joining me on this explainer, and keep exploring.